Okay, the table shows the distance y a cheetah can travel in feet in x seconds. So you have a table, it gives you the seconds, and then it gives you the distance in feet. So based on the information in the table, which equation can be used to model the relationship between x and y? So what you're doing, you are doing the change in x and the change in y. So you go ahead and find the difference. So 5 to 10 is plus 5. 10 to 15 is plus 5. Okay, from the distance, you have 470 to 940 is going to be plus what? 470. So it's the same for the next one, 470. Okay, so now what we do is we do the change in y over the change in x. And that's going to give you 470 over 5. And you simplify it. So 5 into 470 is 94. So in this case, that's going to be 94x. Now, if I go back to 0, so if I go back, I'm subtracting 5 here. So I'll be subtracting 470 here. So that's 0, 0. So that means there is no, the y-intercept or the initial amount is 0. So then that's going to equal to y equals 94x. And there you go. Another way you could check is just substitute the x. So if they're telling you x is 5, you do 5 times 5, and that gives you 25. So that means that y is not 25 here, so that's wrong. What I do, I always check the third one, because usually the first one, you'll have an equation that matches that. The second one might be matching too, but the third one is the one that tells you for sure which one it is. So all you have to do is substitute x. So I know here if I do 15 plus 5, that doesn't give you 1,410, right?
No.
No. If I do 15 plus 470, does that give you 1,410?
No.
So the only one left over is letter D. So that's another way you could do it. So use the answer choices they give you just to substitute your x and see if it gives you y. And that's it. Should be easier if you don't remember how to do all this stuff. Okay? Any questions? Okay, so now number 2 is asking you for the angles or for the value of x. So it says the angle measures of a triangle are shown. What is the value of x? So what do we do in order to find that value? What do we know about triangles and the angles? Yeah, the sum of the angles, all the angles in a triangle equals 180. So then what I need to do is just go ahead and put 2x plus 50 plus 3x minus 10. And all of that is going to equal to 180. So I'm going to go ahead and combine like terms. Like terms are the numbers that are by themselves. You combine them. The numbers that have the same variable, you combine them. So I have 50 and negative 10. So I'm subtracting that. So 50 minus 10 is 40. Okay, I'm also going to do 2x and 3x. So that's going to give you 5x. And then that all equals to 180. Now that we combine like terms, then we could go ahead and start undoing addition and then multiplication or division. So we're going to go ahead and subtract 40 on each side. So that means 5x equals to 140. And when we divide that, x will equal to, what? 28. So that means my answer is letter J. So here x equals 28. Okay, so basically, you have to make sure you set it up correctly in order to find the correct value. Remember, this is all review for your START test. Okay, so predictions using theoretical probability and experimental probability, this is what we did yesterday, and this is what we're going to continue today. So if we look at the information there, we're going to use this table for all the 4 questions under it. So it says a spinner marked with 5 sections, blue, green, yellow, red, and orange, was spun 150 times. The results are shown in the table. So we sometimes are given the table, but they ask for theoretical probability. Now, if you could draw a picture of what they're asking you, it'll be sometimes useful, especially if you don't understand what they're telling you. So what we're going to do, I drew a spinner. This spinner has 5 sections, which is blue, green, yellow, red, and orange. Okay, and this is going to help me with the theoretical probability. The table is going to help me with experimental probability. So if you look at letter A, it's saying true or false. It says the theoretical probability of landing on green is greater than the experimental probability of landing on green. So it says justify your answer. When I say justify your answer, does it mean you're writing it out or are you showing your work? Yeah, you're showing your work. So that's what we're going to be doing. So if you go ahead and I'm going to go ahead and start labeling theoretical probability as TP and experimental probability as EP. So theoretical probability of landing on green would be what? 1 out of 5, because you have one of the sections is green and there's 5 sections all around. So 1 out of 5. Now they're asking to compare it to experimental probability of green. So experimental probability, we know the total was 150 because it tells you up here. And how many times did it land on green? 10 times. Okay, so I could simplify that by dividing by 10. So I'm going to go ahead and divide it by 10. So this becomes 1 out of 15. So now we could compare. Now, I've been telling you to find common denominator. You could do that. You could also find a decimal. And to find the decimal, you divide the fractions. So what would you rather do? Find common denominator or find a decimal? Yeah, because it's easier, right? You could see it right away what the common denominator is. So in this case, what's the common denominator? 15. So I'm going to change 5 into 15. So I'm going to multiply this by 3. So this becomes 3 over 15. Now we could compare. So is 3 over 15 greater than or less than 1 over 15? So it's going to be greater than. So let's look at this. The theoretical probability of landing on green is greater than the experimental probability. Is that true or false? That is true. That is true. Okay, so let's go ahead and do letter B. Okay, letter B, true or false? The experimental probability of not landing on orange is greater than the theoretical probability of not landing on orange. So the experimental probability, they're asking now for experimental probability. So I'm going to go ahead and do EP of not orange. Okay, so what would be the experimental probability of not landing on orange? That's theoretical. We're looking at experimental because they did experimental first. Okay, so I know that it landed 50 times out of 150. So how many did not land on orange? 100. So this would be 100 of 150. We could simplify it by dividing by, 100. Not 100, 50. So this becomes 2 out of 3. Okay, now we're going to go ahead and do theoretical probability of not orange. And theoretical probability of not orange is 4 out of 5. Okay, so now we have to compare it. Now, like I said, we could change it to a decimal. So 2/3, in order to change it to a decimal, and we're going to do that one, is divide. So we're going to divide 2/3. 2 divided by 3. You add a decimal and a 0 because I know that 3 does not go into 2 at all. So that's going to be 0 times. So 3 into 20 is 6 times. So that's going to be 18. Your remainder is 2. If I add a 0 and bring it down again, what's going to happen? 3 into 20 is 6 times. That's going to give you 18 again. Right? Then it's remainder 2. Add another 0 down. What's happening, guys?
It's repeating.
Yes, it's a repeating decimal. So this is going to be 6/10 repeating. Okay, now 4/5, we're going to go ahead and find a decimal for that. So 4 divided by 5. Well, 4 and 5 doesn't go into 4 at all, so I'm going to add a decimal and a 0. So how many times does 5 go into 40? 8 times. So that is a terminating decimal. So this is going to be 0.8. So now you're comparing, is 6/10 repeating greater than or less than 8/10? It's less than. So let's go back to the question. So it's saying, true or false, the experimental probability of not landing on orange is greater than the theoretical probability of not landing on orange. Is that true or false? That is false. So we circle it and we're done with those two questions. So basically, what we did is what we've been doing for the last 3 days, 2 days, 3 days. What we're looking and comparing theoretical probability and experimental probability. And like I said, if you need to draw a picture for theoretical probability, go ahead and draw it because sometimes it's easier to see it that way than just to figure it out. Okay, so letter C, we're still using that table for the experimental probability. So it says, if the spinner spun 50 more times, how many of these times would you expect the pointer to land on blue? Okay, so we still need to use that table. So we know that we're looking for blue because we're doing a prediction. We're going to use that one table or one chart. So blue over total. Okay, on the table, how many were landed on blue? 14. And we know that it was a total of 150. Okay, if I look at the new one or the prediction, they're spinning 50 more, so that means my total is going to be 50, and they want to know of those 50, how many would land on blue. So if you look at this, can we find a scale factor? 150 is going to 50, and you would need to do what?
Multiply 14 and 50.
Okay, that's one way. You could do cross products, so you could do that. Or you could also find a scale factor. So from 150 to get to 50, you divide it or you multiply it? Divide it. So 150 divided by what will give you 50? 3, right? So that means if I divide that by 3, then I'm dividing 14 by 3. So let's go ahead and do that. 14 divided by 3, because either way you're going to divide. So find an easier number, because if you multiply 50 times 140, you're going to divide large numbers. So 3 into 14 is 4 times. That's 12. Remainder is 2. Add a decimal and a 0 because we need to keep going. 3 into 20 is 6 times. So that's 18. Remainder is 2. So that's gonna be repeating, right? Is that repeating decimal? Okay, so it says about how many times? Or how many times are you expected? So that means, is it 4 6/10 repeating? Can we write that? No. So then it would be about how many times? 5 times. So this would be our answer. So out of 50, if they spend 50 more, then we can expect the spinner to land on blue 5 more times. Okay, now let's go ahead and look at letter D. Letter D says, if the spinner spun 250 times, how many times would you expect this pointer to land on green or orange? So now we're doing the probability of green or orange. And remember, we have to add those two parts in order for us to know this. So I know that the total was still 150. So how many are green? So green, there's 10, right? Orange, there's 50. So if I add those up, that's going to be 60. So 60 out of 150 is landed on green or orange. But now they're asking for 250. Now, in this case, you could do cross product again, but I always like to find a comment or a scale factor in this. So remember, if they end in zeros, you could divide by 10, right? Well, if you divide by 10, you just get 6 and 15. So I cross those zeros out. Always cross those zeros out if you have a 0 and a 0 on top. There have 2 zeros on top and 2 zeros on the bottom. You cross both zeros. Okay, so but they have to be the same amount. Now we have 6 15s. I could still make it smaller, right? I could still simplify it. So we could divide it by what in this case? By 3. So we're going to go ahead and divide it by 3. So if I divide this by 3, this becomes 2. If I divide this by 3, it becomes 5. So now can I find a scale factor? Yeah, by 5. So 5 times 5 is 250. So it's what? 50. So 5 times 50 gives you 250. And 2 times 50 gives you 100. So would you rather deal with big numbers, multiply them, and then divide them with big numbers? Or would you rather find a scale factor? Yeah, it's up to you. Scale factor to me is easier. Sometimes you won't be able to find a scale factor, and that's you go to the last resort. Your last resort is to multiply, okay, cross product. But if you can find a scale factor, always try to simplify your ratio before you go on to the next prediction. Any questions on this? No? Think you got it? Because you're going to practice. Okay, so here is your assignment. It is 10 questions. Again, you do need to work on it. Make sure that you are answering and showing your work, not just circling answers. There are some parts that have, no, actually this one doesn't. So do you have multiple choice questions and you have open-ended questions? And most of them you have to find experimental, theoretical from the same thing that they're telling you, and then comparing them. So you got to compare them. Also make sure that you are predicting, you're setting up your one chart to help you see what you need to multiply, what you need to divide. So I'm going to go ahead and give you this handout, and remember, this will be in the Google Classroom. You will be able to watch the video again. Also, I always put extra videos so you could see other examples, and sometimes I include online games for extra practice. If you guys haven't gone to Google Classroom, this is the time to do it, because I'm going to start putting also review videos for what we're going to be doing for the STAR testing. You do have a CDB also coming soon, so guys, we don't have a lot more time. It seems like we do, but we don't. Okay. So go ahead and put this quick check in your composition book.